So we're doing chapter 5.1, which is using fundamental identities.
Sine equals 1 over cosecant. Cosine equals 1 over secant. Tangent equals 1 over cotangent. Cosecant equals 1 over sine. Secant equals 1 over cosine. Cotangent equals 1 over tangent. These are the fundamental trigonometric identities.
So now we're doing Pythagorean identities. First we have sine squared theta plus cosine squared equals 1, and then 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. For these functions, sine times negative theta is negative sine. Cosine times negative theta is positive cosine. Tangent times negative theta is negative tangent. Cosecant times negative theta is negative cosecant. Secant times negative theta is positive theta. And cotangent times negative theta is negative cotangent.
For our first example, sine x times cosine squared x minus sine x. So that simplifies to sine x times cosine squared minus x minus 1. We know that because sine squared plus cosine squared equals 1. So we got to 1 minus cosine squared x by simplifying. Our final answer is negative sine. Our negative comes from the 1 minus cosine squared. Negative sine x times sine squared x, because sine squared plus cosine squared equals 1.
We're moving on to factoring trigonometric identities. Our first example is A, which is secant squared times x minus 1. Through basic factoring, we're able to get to secant x minus 1 multiplied by secant x plus 1. In our next example, B, we have 4 tangent squared x plus tangent x minus 3. So we reduce that equation into 4a squared plus a minus 3, where a is equal to tangent. Moving on, we get negative 4a minus 3 multiplied by a plus 1, and our negative is coming from the negative 3. Then by adding tangent back into the equation, we get 4 tangent x minus 3 to tangent x plus 1.
Now on to real-world applications. You can find unknown angles, find unknown side lengths, and it's often used in architecture and engineering.
So now we have the quiz. Moving on to part A, we have secant x over cosecant x. And that equals 1 over cosine x over 1 over sine x. We know this because secant equals 1 over cosine, and cosecant equals 1 over sine, as we could see on the paper we showed before. The equation then reduces to 1 over cosine divided by 1 over sine. Using the keep, change, flip method, we're able to get 1 over cosine multiplied by sine over 1. By cross-multiplying the ones out, we get sine x over cosine x. As we stated before, sine x over cosine x could further reduce to tangent x.
Now on to problem B, which is secant squared x times 1 minus sine squared x. This simplifies to 1 over cosine squared x times cosine squared x. We know that because secant equals 1 over cosine. And 1 minus sine squared equals cosine squared. That leaves us with an answer of 1 because you cancel out the cosine x squares.